Okay, so the last thing that I'm gonna help walk you through is the problems on Delta Math where you actually have to graph. Um, so I've written the given problem down. I factored out the 5 on top. That left me the difference of two squares, which factors to x plus 2 times x minus 2. So this is the progression of the factoring that I did on top. On bottom, I first thought I might have to do the AC method because we had a leading coefficient, but I noticed that everything was divisible by 4, so I factored out a negative 4. I don't like my x squared term being negative, so I factored out a negative 4. So 12 divided by negative 4 is negative 3. 40 divided by negative 4 is negative 10. Then I had an easy trinomial, two numbers that multiply together give me 10, 2 and 5, 1 and 10. I need to subtract to give me 3, so that left me with 2 and 5. I know that 1 is going to be positive and 1's going to be negative because the 10 is negative. So I put a positive and a negative, and then I looked at this one and said the bigger number has to be negative. So I put the 5 and then the 2. Okay, so the first thing I'm going to deal with is the whole. The whole is you find the x value of the whole by solving the common factor. The common factor is x plus 2. You set it equal to 0 and solve. Subtract 2 from both sides. So I know the x value of my whole is going to be negative 2, and then I plug that negative 2, I said right here, plug the x value into the simplified rational. So we cancel out that common factor. That leaves me 5 times x minus 2 and negative 4 times x minus 5. I plugged in this negative 2 or this negative 2 right here. I plugged it in the place of those x's. And you can do that on Desmos. As long as you name it a fraction, as long as you name it a function, give it a function name, then you can plug it in. I'll show you what I mean. Okay, so as you can see, I graphed the original given function. It's showing up in red. And if you plug in negative 2 into the given function, it tells you that it's undefined because why? We have a hole there. So you can't plug it into the given function. You have to plug it into the simplified. So notice my x plus 2's are not up here. So you plug in negative 2 into the simplified version and it gives you the y value. And you can see it right here if you go plug in. Now, see it showing you right there that the red function, it's undefined, and that's actually what it's going to look like when you do it when you place the whole. In just a second, I'm going to show you when you place the whole on Delta Math. That's exactly what it's going to look like. But if you turn that one off and trace this one, it looks identical. See, there's the red one, there's the green one. It looks identical. The only difference now is if you go trace it on negative 2, you get a y value, and that's the y value that they're giving you right here. Notice those are the exact same, negative 0.714. And over there on the slide right there, it says negative 0.714. It gives you some more decimal values there, but right there, we get about 3 decimal places. So you can use Desmos to do that. If you're taking a quiz or taking a test, you may have to do some mental math, but I will make sure that it's one that simplifies out a little bit better and not have mental math where you have to come up with this negative 0.714 answer. Okay, so that's why you have to plug it into the simplified one, because the simplified one has a value there. The given one, it literally shows the whole. When you pass over negative 2, it tells you that it's undefined, just like it's telling you right here that it's undefined. Okay, so on Delta Math, you click that you're going to put the whole on there, and the hole pops up, and you just have to place it in the right place. I mean, you can move that around. So we know it's going to go at -2 and then down to 0.7 something, 0.71, something like that. So it's not quite down as far as 1, so I'm going to leave the hole right there. Okay, so the next thing we're going to do is the horizontal asymptote. The horizontal asymptote is Bobo Biden eats DC. As you can see right here, the exponents are the same. So this is the outcome right here. So we divide the two leading coefficients. So it's 5 over -4, which comes out to be 1.25, negative 1.25. Divide the coefficients. So the coefficient in front of this squared term is 5. The coefficient in front of this squared term is -4. 5 divided by -4 gives us negative 1.25. So the horizontal asymptote needs to be at negative 1.25 and a little bit more. So there's, again, you just move it. It pops up. It popped up in that place because I've already worked this problem, but it popped up, so that's why it remembered where it was. But negative 1.25. Do I know exactly if that's at 0.25? No, but it's not quite a half. So I think I'm pretty comfortable with that location. The next one is, let's see, what can we do next? We did horizontal asymptote. Let's do vertical asymptote. How do we do the vertical asymptote? We set denominator equal to 0. And I'm talking about the simplified version. If we set the whole denominator equal to 0, we would include that whole. So we're only going to go to the simplified, and we're set the denominator equal to 0. So we're going to take -4 times x minus 5 and set it equal to 0. Now solve for x. We've got to undo this multiplication. What do? Divide both sides by -4. 0 divided by -4 is 0. Get the x by itself. So add 5 to both sides, and it comes out to be x equals 5. That's your vertical asymptote. So you click the vertical asymptote and you move it to wherever it goes. We said it should be at x equals 5. What else can we do? We can do, we've got to do the x-intercept. How do we do the x-intercept? For x-intercept, we set numerator equal to 0. So the numerator of the simplified version, So take 5 times x minus 2 and set that equal to 0. Divide both sides by 5. You get x minus 2 equals 0. Then solve for x. Add 2 to both sides. You get x equals 2. So your x-intercept is going to be 2, 0. So you click on x-intercept and it gives you a point, and you just move it to the correct place, 2, 0. The last thing it looks like we need to find is the y-intercept. And how do we find the y-intercept? I am all out of room. For the y-intercept, we plug in 0 for y. Plug in 0 for, I think I said y. You plug in 0 for x. So the y-intercept, you again go to the simplified form, and we're going to plug in 0 for x. So we're going to take 5 times 0 minus 2, and we take -4 times 0 minus 5, and then you simplify that. So that's 5 times -2, that's -10, that's -4 times -5, that's +20. So that comes out to be -1/2. So the y-intercept is 0, -1/2. Now you click on y-intercept, and it gives you a dot along the y-axis. You move it to where you think it is, and now you plot the rational function, and it should give you the curves. By making it pass through those points and making it hug the asymptotes. So that's how it knows where to go. All right, so that should get you through the problems where you have to graph.